this next example is actually a difficult problem as it will involve double substitution. Now, notice that the difference between the highest degree in our numerator and our denominator is not 1. What this means is that I cannot treat the denominator as my u, because if I'll show you that if our u is 4x to the 4th minus 4x squared and then plus 1, our du will be 16x and then cubed minus 8x, and then we have dx, and so our dx will become du divided by 16x cubed minus 8x. And so if we will substitute this here into our dx, notice that we cannot eliminate the variable x because it will look like this. This is the integral of x, and then this is our dx. We have du and then over 16x cubed minus 8x, and then divided by 4x to the 4th minus 4x squared and then plus 1. Now, I can factor out x here, but then again, there will still be a variable x in my equation, and so this will just be useless. And so let me just erase this one. Now, you have to remember that your u should only be 1 degree higher than the numerator or the denominator, depending on which you want to cancel. Thus, to solve this problem, our u must be x squared, so that it will only be 1 degree higher than the degree in our numerator. Because again, this is x to the power of 1. And then if we will move 1 degree higher, we have x squared. And so it will be ideal to use this as our u. And so let's try to do that. And so let me just delete this one. Our u will be equal to x squared. Now, differentiating u with respect to x, we have du is equal to 2x times dx. And so if we'll isolate dx, we have dx is equal to du divided by 2x. Next, we will apply u into our original equation. Now, notice that our u is x squared, and so I can actually replace these. Now we have 4x to the 4th, but I can just replace that with 4 times u and then squared, because again, our u is x squared, and then if we will square that, we will get x to the 4th. And so that's why this expression will just become 4x to the 4th. And then we have 4x squared. Now I can replace x squared by u, and so I can just actually write this as minus 4u, and then this is again 4u squared, and then we have plus 1. And so this is how I'm going to rewrite my denominator. And then we'll also replace dx by du over 2x. And so applying that, we have the integral of x and then multiplied by du over 2x, because we will replace this one. That will be divided by 4u squared minus 4u and then plus 1. So this is 4u squared minus 4u and then plus 1. And so notice that we can actually cancel x. And so this will cancel and this one. And so our numerator will become du over 2 and then divided by 4u squared minus 4u and then plus 1. Now, du over 2 is just equal to du times 1/2. And so let me just rewrite this one. This is du times 1/2. And then since this is just a constant term, I can just move that outside. And so let's just move this here. And then let's actually consider this expression. Now, if you look at this function, you still cannot apply a general integration formula for this. Thus, we will do another round of substitution. In this substitution, we will now use v instead of u. However, take note that we will not treat 4u squared minus 4u plus 1 as our v, because differentiating this function, we have, let's say we consider that as our v, we have 4u squared minus 4u and then plus 1. However, if we will differentiate this, we have dv is equal to 8u minus 4. Again, we are differentiating with respect to u. However, this will not do anything because we need to only have a variable v in our new function. However, since this has u, this will not change a thing. Now, a strategy you can apply here is you can actually factor this one. Now notice that this is just a square of a binomial. And so let's just copy this one. Recall that the square of a binomial expands into a squared plus 2ab plus b squared. Now, our a squared is 4u squared. And then our b squared is actually 1. And so taking the square roots, we can now solve a and b. Now our a will just be the square root of 4u squared. And then our b will become the square root of 1. Now, the square root of 4u squared will become 2u, because again, we will take the square root of 4, which is 2, and then the square root of u squared will become u. And then for b, we have square root of 1. Now, the square root of 1 may be negative 1 or positive 1. However, we will actually be taking this value because the sign of our middle term is actually negative. And so take note that this is our a and this is our b. And so we can now rewrite this one. Let's convert this into this form. And so we have our a is 2u, and then our b is -1. So this is -1 and then squared. And so let's just copy this one. And so this will be our function. However, even if we have factored this one, we still cannot apply direct integration techniques. And so what we will do here is we will apply another substitution. And then here, we will just be using v. Now, notice that 2u minus 1 is a function with the highest degree of 1. And so I will actually treat that as my v. Because notice that in the numerator, we don't have any expression. And so we don't want to cancel any variable. So that means that my v should only contain a constant term once I will differentiate it. And so using this as my v, I have 2u minus 1. And then differentiating with respect to u, we have dv is equal to 2 and then du. And then isolating du, we have du is equal to dv divided by 2. And so I can now rewrite this one. And so I have 1/2 times the integral of du, which is just dv over 2. And so this will become dv over 2. And then we'll divide this by 2u minus 1 squared. However, note that 2u minus 1 is my v. And so I will replace this. That will become v and then squared. Notice that this only contains one variable v. And then we have dv. And so now, we have made our function integrable. And so let's just first simplify this one. Let's move the constant term outside. That will become times 1/2. And then let's just remove 2. Now, 1/2 times 1/2, that will become 1/4. And then we'll just actually integrate dv divided by v squared. And then we'll just move this up so that we can integrate easily. And so we have 1/4 and then the integral of v to the power of -2 and then dv. And so here, we can apply the power rule. So this will become 1/4 and then multiplied by v to the power of -2 plus 1 divided by -2 plus 1. And so this will give us 1/4 times v, and then -2 plus 1 will give us -1. So this is -1. And then divided by -2 plus 1, that will also give us -1. So this is -1. And so I can just actually move negative outside. And so this will become minus 1/4 times v to the -1. And then since our exponent is negative, we can just actually move that down. And so we have minus 1/4, and then let's move v down. It will be here. So we have -1/4v. And then let's not forget our constant of integration. So we have plus c. And so this will be our answer. However, we need to substitute back our original equations. Now take note that our v is just equal to 2u minus 1. And so we will now change this one. Let me just copy this. And then let's also look at our u. Our u was x squared. So we'll also copy this one. And so here, we have minus 1 divided by 4. And then our v is 2u minus 1. So this is 2u minus 1. And then plus c. And then we'll change u into x squared. So this will become -1 divided by 4. And then 2 times x squared minus 1. And then plus c. And then let's just distribute this one. So we have minus 1/8x squared and then minus 4. Because 4 times 2x squared, that will give us 8x squared. And then 4 times -1, that will give us minus 4. And then we have plus c. And so this will be our answer. And so if we'll check this one, we'll type this into ddx. We have -1 divided by 8x squared minus 4. And then let's just input any value here. Let's say 6. And so our result will be 6 divided by 5041. So we will just store that at a. And then let's go back to our given. Now our given is x dx divided by 4x to the 4th minus 4x squared plus 1. And so writing that here, I have x and then 4x to the 4th and then minus 4x squared and then plus 1. And so substituting 6, I have 6 divided by 5041, which is just the same as earlier because this is our a and this is our b. And so this means that our answer is correct. Now just take note that if you can't directly integrate something after applying substitution, then that means that you can actually apply another round of substitution and then just use another variable. And so if you will be able to master this one, then you will be able to integrate just about anything. However, the more efficient way would be to factor this in your first step. Now this is just a square of a binomial. And then if we'll factor that, the square root of 4x to the 4th will be 2x and then squared. And then the square root of 1 will be 1. And so if we'll factor this expression, we have 2x squared and then minus 1 and then squared. Now, the double substitution will only be useful if you will not be able to see directly that this is a square of a binomial. And then it can also be applied to more advanced problems. However, this is the optimal solution. Now if you will replace this one, we have the integral of x dx and then divided by 2x squared minus 1 and then squared. And so now I can actually treat this as my u. And so I have u is equal to 2x squared minus 1 and then my du will be 4x dx. And then my dx will be du divided by 4x. And so substituting this into our dx, we have the integral of x times du over 4x divided by u and then squared. And so this will cancel. And then let's just move this outside. We have 1/4 and then the integral of du divided by u squared. And then we can rewrite this as 1/4 and then the integral of u to the negative 2 times du. And so integrating this, we have 1/4 and then u to the minus 2 plus 1 divided by negative 2 plus 1 and then plus the arbitrary constant. And so we have 1/4 times u and then this will become negative 1 and we have divided by negative 1. And so we will move negative outside. We have negative 1/4 and then let's just actually move this down. So we have u here and then plus c. And so now we will replace our u with 2x squared minus 1. And so this will become 1 over 4 times 2x squared minus 1 and then plus c. And so notice that this is just the same with our answer earlier, which is minus 1 divided by 8x squared and then minus 4 if we'll distribute this, and then we have plus c. And so in your exams, it would be best to follow this process. However, I'm just teaching you this one so that you will be able to apply this in more complicated problems. And so I hope this video helped you.